Hello, I'm Apurva Mody, founder and CEO of Aeronaculus and National Spectrum Consortium Executive Committee member. The National Spectrum Consortium is a research and development organization that incubates new technologies to revolutionize the way in which spectrum is utilized. As part of that work, we have organized working groups and task groups to serve as collaborative platforms between industry, academia and governments. These groups leverage the expertise of NSC's members to inform national policy and commercial standards and advance US competitiveness. Today, we are here to talk about the new recommendation on tactical data links and electronic news gathering systems with the co-chairs and chief technical advisor of our MIL-CIV task. Thank you all for joining us today. Joe, could you start by introducing yourself?
Thank you. My name is Joe Molnar, and I'm the branch head of the Networks and Communication Systems branch at the Naval Research Laboratory.
Thank you, Joe. So Sastry, do you want to introduce yourself?
Sure. My name is Sastry Kompella. I'm currently the chief scientist of a NSC member company called Nexcepta. Until recently, and mainly during the course of this working group exercise, I was the section head at the US Naval Research Laboratory under Joe Molnar, where I ran the wireless network research section under the Information Technology Division.
Thank you, Sastry. And Tommaso?
Thank you, Apurva. I'm Tommaso Melodia, professor of electrical and computer engineering at NSC academic member Northeastern University, where I also direct the Institute for the Wireless Internet of Things. Happy to be here today.
Thank you, Tommaso. I have worked with all of you, and the work that we have produced, the work product is really phenomenal. Amongst everything else, all of you are great friends as well. So thank you so much for joining. So Joe, can you tell us a little bit more about how this task group came about?
Sure, perfect, thanks. I was the project manager for a spectrum research and development project involving a tactical data link that had the ability to use the 2025 to 2110 megahertz band. And it was had the ability to do that as a primary user, but with shared access and a not to interfere criteria with the ENG band. And so having that primary status, but with a not to interfere capability meant that there was a number of technical challenges that are associated with that. So those brought up major concerns, and the way to address that was not really solved in any sort of technical manner. So I knew that the NSC provided a wealth of technical expertise and talent to address problems. And the OSD R&E program manager for spectrum research and development, Ellen Purdy at the time, was the contract manager essentially for the Natural Spectrum Consortium. And it seemed as though it provided a great opportunity to use the consortium as a technical resource for establishing a practice and technical solution for how to address this problem.
Got it. And then why especially 2025 to 2110 megahertz of spectrum?
Well, it created a important part of the band because it was the military had basically lost the ability to access the AWS-3 band as part of the auction. And so there was a condensed band in AWS-3, and many of those systems needed a lot of spectrum. The tactical data link was one of them. And the band that was offered as a shared solution was the 2025 to 2110 band. So that's how that band became available to the DoD and the military users. but there was no real solution on how they were going to use it. And many of the tactical data links are on aerial platforms that have a long visibility range in RF.
Got it. So, Tommaso, do you want to talk a little bit for our audience, which doesn't really know much about spectrum sharing? Like, can you explain to us what are the traditional spectrum sharing approaches?
Sure, Apurva. So there are a number of ways to avoid interference in spectrum sharings, right? So we can focus on three classical approaches. So first basic approach mainly boils down to creating an exclusion and protection zone around the victim receiver in the area where a transmitter may cause interference above a certain level, right? And this approach suffers from a few issues, but the main one is that it assumes that the receiver is actively receiving signals 100% of the time. And therefore, any transmitter around it will have to avoid transmitting while in the area, in the exclusion or protection area, 100% of the time, which may be overly pessimistic and conservative and can lead to waste in spectrum in both time and space, technically speaking in low bits per second per hertz per square meter. Now, another approach requires a centralized spectrum access system, so referred to as SAS, that will manage spectrum access for a collection of radio systems according to some pre-accepted spectrum sharing policy that everybody agrees to. And this usually requires a pre-populated database that contains this information. And the main drawback of this approach is that it needs longer time scales for coordination and needs to keep the database current, right? Which is not always easy. And this is especially true when you have dynamic situations where the RF environment is changing continuously, rapidly, and there is mobility involved with which happens in a lot of fast-moving scenarios. The third approach is a sensing-based dynamic spectrum access solution that works on the principle of sensing the signal to be protected. If the dynamic spectrum access system detects the victim signal, then any transmitter that may potentially cause interference to the receiver may be switched to a different frequency. And this approach eliminates both the temporal and spatial waste of the geographic approach that we discussed earlier, because the DSA system will only turn off if the victim signal is actually present. However, sensing-only approaches may not always protect the victim receiver because of something called the hidden node problem, situations where the dynamic spectrum access system may not be able to detect the primary transmission.
Got it. This was truly explained as a professor. You know, I got it. Thank you so much, Tommaso. So, Sastry, do you want to talk about in the MIL-CIV task group, the spectrum sharing task group, what were the main recommendations and how they differ from the status quo?
Sure, thanks, Apurva. The two themes that are central to our recommendations are as follows. One is the mechanisms need to be hybrid in nature. And the second important theme was cooperation. For example, the first recommendation is a combined beaconing and sensing approach. This is a hybrid approach where the ENG receiver transmits a DRL signal for the duration of the time that the ENG signal is active. This is done through the help of a beacon that is co-located with the ENG receiver. The second recommendation that we had is again a hybrid approach that combines the centralized spectrum coordination approach that Tommaso just talked about with distributed sensing. This is the distributed sensing part is usually done using a sensor system that provides like an environmental sensing capability, also known as ESC. Folks who understand CBRS systems know about this kind of structure that is prevalent. The third approach employs a direct measurement of interference level at the incumbent ENG system receiver. If the interference level exceeds a predefined or predetermined coexistence threshold, then the system control processes are executed to adjust system parameters. So there is a feedback mechanism inherently built into this approach. Finally, in the report, we talk about a very cooperative scheme that has the potential to greatly improve spectral efficiency through a near real-time spectrum coordination mechanism. This is designed specifically for the incumbent system operators so that they can use their existing spectrum-dependent systems without modification. This is called Incumbent Informing Capability, or IIC. One of our recommendations here is to develop a IIC-based app that would collaboratively improve opportunistic spectrum access. This app has the added advantage, meaning that it has the ability to provide new entrants along with nodes that are already within the shared spectrum band with localized spectrum situational awareness. So a new entrant can come immediately equipped with what is happening in its localized area. So this is how we have structured these recommendations.
Yeah, so this certainly shows us the depth and the breadth of expertise at the National Spectrum Consortium. We really understand the problem. So what are the most important recommendations as a result of this process? Sastry.
Right. So we set out to develop recommendations for efficient spectrum sharing between TDL, tactical data links, and ENG. We have in the document, we actually provided a table, table 3 specifically, that describes the advantages and constraints with each of these recommended approaches that we came up with. Additionally, we talk about one aspect, cost versus performance trade-offs for each of these recommendations. The main conclusion is that the best performance is obtained by understanding the use case thoroughly that we are trying to apply these recommendations to, and tailoring one or more likely a combination of the sharing approaches that are highlighted in the document to that specific use case.
Got it. So in future, we will be bringing in the TV broadcasting ecosystem as well as the DoD ecosystem together, right? And then having a discussion on which of these recommendations would be something that especially the incumbents like the TV broadcasters will accept. Is that correct?
That is right. And this mechanism that we came up with, what we have worked on, actually provides a blueprint for going beyond MIL-CIV to MIL-FED, those kind of approaches as well. And we already are seeing that some of the other NSC working groups have taken this approach and started adapting the recommendations that we have come up with to their use cases.
Got it. So Joe, do you want to tell us what is beyond this task group now? What is the next activity that we are going to embark on? Or are we going to expand this group by inviting TV broadcasters to figure out that what is the next step with them?
Yeah, so I think the main work of the task group is completed. The purpose was to generate this recommended practice, and that has gone through public release through the DoD and released by the executive committee. And so it exists in the public domain. The next step is to coordinate with broadcasters to make them aware of this capability and coordinate with the DoD to, although they've been following this and are well aware of it, to see, well, how do we exploit the capabilities and the practices that are inculcated in this practice and really make it possible for tactical data links to share in this environment with the broadcasters.
Got it. Thank you all. We had a distinguished panel today. You guys are really the cream of the crowd in terms of spectrum sharing. I had a pleasure of hosting this brief conversation. But to read the full recommended practice on this TDL or tactical data link versus electronic news gathering system, please visit our website, which is nationalspectrumconsortium.org. Please also become a member. Along with meeting great minds, we will also be able to propose to different topics, which is good for your company. So many thanks for that. Thank you so much.
Thank you.
Thank you, Apurva.
Thank you.